In this video, you will learn about coordination compounds. To begin with, a coordination compound is composed of a transition metal and ligands, which bind together to form a complex. One concept to know is that the coordination number of a coordination compound equals the number of bonds. If the ligand binds at one site, it is called monodentate. If it binds at two sites, it's bidentate, and three sites, tridentate, and so on. Four ligands you should be familiar with that are not monodentate include ethylene diamine, diethylene triamine, ethylene diamine tetraacetato, and oxalato. Now let's do an example that involves finding the coordination number and shape of a coordination compound. In this example, we see that there are 6 monodentate cyanoligands binded to the iron central metal ion, so the coordination number is 6. This therefore makes the shape octahedral. Another concept to know is how to decipher whether the coordinate compound is cis or trans. In the first example, we see that the chlorines are opposite from each other. This would make it trans. In the second example, we see that the two chlorines are next to each other. This would make it cis. A neat trick to remember is that cis kind of sounds like sister or same. A third concept to be familiar with is oxidation number. The oxidation number of a central metal ion in the coordinate compound equals its charge. Now let's do an example that involves finding the charge of the central metal ion of this coordination compound. Here we see that the 3 amines have a neutral charge. The 3 chloros have a -1 charge each, and the sodium ion on the outside of the brackets has a +1 charge. In order for the coordination compound to be neutral, this cobalt will need a +2 charge. Therefore, its oxidation number is 2. The last concept we're going to cover is how to name coordinate compounds. When naming, you want to name the ligand before the metal ion. You also want to use prefixes to indicate the number of ligands, using di, tri, tetra, penta, hexa. However, if the ligand name already has a di or tri in it, you would use bis, tris, tetrachus, and so on. If the complex has a negative charge, you would add 8 to the end of the metal name. For example, platinum would become platinate, nickel would become nickelate, and iron would become ferrite. Now we're going to do some examples with naming. To begin with, we start with naming the ligands in alphabetical order. So first would become chloro, then cyano, then our ethylene diamine, but take note that there's a subscript of 2, so this would become bis ethylene diamine, and then comes our central metal ion, cobalt, along with its charge, and then chloride, which is outside of our coordinate sphere and brackets. To find the charge of cobalt, we know that cyano has a -1 charge, chloro has a -1 charge, ethylene diamine has a neutral charge, and that this chloro has a -1 charge. To balance out, our cobalt central metal ion would need a charge of +3. For the second example, we are going from the name to the formula. In this example, we first write down the potassium because this has a positive charge and goes before the coordinate sphere. Next comes our central metal ion, nickel, and then our cyanoligand, which has 4, tetra. To find how many of the potassium ions we would need, we take note that the nickel, it's given that it has a +2 charge. We also know that each cyanoligand has a -1 charge. As of now, the coordinate sphere, has a -2 charge, and each potassium has a +1 charge, so we would need 2 of these. So you would add a subscript of 2. In our third example, we start with naming the ligands in alphabetical order. So first would come aqua, which starts with the letter A, and because there are 5, you would put prefix of penta, aqua. Then comes hydroxo, and lastly our central metal ion, iron, which has a +3 charge. And we know this because the hydroxo has a -1 charge, the waters, or aquas, have a neutral charge, and our coordinate sphere should have a +2 charge. In order to get this to happen, we would need iron with a +3 charge. And lastly, we write ion. Thank you very much, and I hope this video was helpful.